Okay, I'm going to talk about one issue that when I was looking into an allocation problem for the RIR policies, I dug deeper and deeper, found what I think is a problem, and what I think can be done to fix it, but I can't do that alone. So IPv6 has been in development for a long time, it has a few warts, and some of those are actually affecting the ability for deploying IPv6 as a IPv4 replacement. We can't really fault the IETF, they're not operators, but we do need to do something about it. There's not a lot of router space, not a lot of router slots available for doing dual core. In order to actually deploy IPv6, it needs to be like a wafer-thin mint as opposed to a really big meal. Yes, IPv6 has lots and lots of bits, but they aren't really all usable for the kind of networking we as network operators know how to do. The problem is one of the IPv6 features which is mandatory for conforming implementations on end hosts is auto-configuration. And because it exists, people are likely going to want to use it. It's a one-size-fits-all. EUI64 was chosen to be the interface identifier, which means that it has a significant impact on the space that's available for actual networks. What is it? EUI64 is like a MAC address, only it's got more bits. It was originally intended for future developments where MAC addresses needed to have a lot of more bits. But other than that, the first 24 bits between MAC 48 and EUI64 are exactly the same identifier. It's an OUI. What uses it? Right now, IEEE 1394, and I'm not aware of anything else that actually uses it from broadcast networks. Why was it chosen? Well, it was picked in 1997 because FireWire seemed to be the hot new thing, and in order to make it forward compatible and backward compatible, everything should use EUI64. What about what we're actually using largely on the end networks these days? 802, everything. There's a mapping. They take MAC 48 and they add another FFFE in the middle. So effectively for the vast majority of deployed end devices, the 16 bits have been wasted. Can't we ignore Autocom? No, it's mandatory. And that means because some people are going to be using it, we have to support it for everybody as an allocation, smallest possible network unit for end user sites. What's the big deal? Well, the Unicast space is only a /3, not the whole of the 128 bits. We know that allocation on a hierarchy from IANA, they're giving it /12s to RIRs. RIRs are giving /32s to ISPs. And ISPs have effectively a decision to make. They can either give a really small space, 64s or 56s, to be good network citizens, but they are effectively cutting their own throat comparatively by not giving it as big a space as their neighbor. But if you give it a big space, you don't have much left internally for your network allocation and aggregation. What we end up with is 12 bits for a typical size ISP, not one of the gargantuan guys who are getting /19s. If you get a 32 and you're reserving /44 for your customer, you only have 12 bits left over. But this is for long-term use and internal aggregation. It really squeezes the ISP. Router slots are expensive. We need to minimize the prefix count for a long time because of the dual stack issue. We need to avoid having a proliferation of IPv6 prefixes wherever possible. Internal router slot use is also a big cost. So because of that, we want to do internal aggregation as a network operator. How is that different from IPv4? Well, IPv4 allocations to ISPs were never done on a very long scale, 6 months. And those were typically only the next size up that you expected to use in that time. It made it difficult to allocate in a way that you could aggregate, effectively everybody is doing internal fragmentation. This is about long-term resource management. Ideally, everybody should be able to take a prefix that they get from their RIR, use it for a very long time, give it out to their customers, have their customers use that prefix that they get for a very long time. And to make it scale, to be able to do internal hierarchical aggregation. Otherwise, everything just does not scale. What would be an ideal size for internal aggregation? About 20 bits. How am I doing on time? 5 minutes. Okay. If we were able to do 20 bits on an allocation, that would really be nice. If we had, for instance, LANs that were using MAC48 as a /80, customers getting a whole bunch of address space that they can use as a /60, ISPs getting /40s, 20 bits on each of them would last a long, long time. Ideally, keeping it nibble aligned for good reverse delegation. 20 bits lets you do lots of levels of aggregation and have a lot of flexibility on how you do that. There are implications on how many routes you need to carry when you're doing non-aggregated internally. If you have 1 million routes, 1 million end-user prefixes, if you don't aggregate on your allocation, if you don't do it hierarchically, allocate out pieces of your space, break it up into bits of address space that are topologically used for sub-allocation to individual customers in the region. If you don't do that, you have just a big mess and you have to carry all those prefixes individually. If you break up your blocks and sub-break up those again and then start allocating out of the smaller pieces, you have the ability to aggregate. The aggregation, the number of prefixes you're going to have is going to be driven by the size of your largest block, not the total number of prefixes. If you take 20, break it into 5, 5, and 10 bits, you're only going to have to carry on your edge routers about 1,100 prefixes. The rest of your internal network you can actually make do with as few as 64 routes. Router slots cost money. Even if it's not a problem for you, even if you get a /12, if other people have to go back and get more and more and more prefixes, they're eating slots in your routers if you have full routing table. Everybody loses unless everybody can aggregate effectively. IPv6 is supposed to be done. Yes, but that doesn't mean that changes can't still be made. I've come up with a proposal I've sent to the IPv6 working group, changing the auto configuration interface identifier size to EUI 48. It means a change to one piece of the IPv6 protocol. It doesn't affect anything else, and it's backward compatible. Where do we go from there? I need help getting people to voice their opinions on the matter on the IPv6 working group. There is a lot of momentum. People don't want to do things that they don't perceive as necessary. I see this as a long-term issue where it won't bite us the first 6 months out of the gate, but a year, 2 years down the road, out of the 10 years that we expect to have, 10, 20 years of dual stack, at some point it's going to be a problem. Better that we nip it in the bud, make the change in one place, and actually fix the thing. The more people we have expressing opinions from the operator side of things, the more likely it is that we can overcome the momentum. All I'm asking for is that people take the time to go and look at things, look at the policy, think about what the implications are, and if you agree, participate in the process. The process is very long. We may need to do certain things in parallel to get the changes made. And the slide is the PDF is on the web. Follow some of these links to get to the interesting information. And at some point, you're going to actually have to come and vote. Vancouver's a very nice place to visit. Are there any questions?
Alan John from Comcast. There's actually a way to allocate longer than 64 without breaking any spec, which is simply to use DHC IPv6.
I understand that, but there's DHC IPv6 is not Autoconf. Autoconf is
DHC IPv6 is part of the Autoconf story. in IPv6.
We can take that offline.
Yeah, please. You've actually had your 10 minutes. Yeah, right. So the next up is Dwayne. Thank you.